Testing 1 2 3. Testing 1 2 3. Testing. Sorry about the wait, guys. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Yo, we are every week on Fridays. Except for last week, I was gone last week. But every other week that I'm here, I stream. What is this? Got a little hair in my lip. We stream Python tutorials for total beginners, introducing not only the basics of Python, but the basics of programming, right, to novices who have never programmed before in their lives. This is our second episode of the season, which means that we've covered the very, 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 very basics from the last episode, including some of these things we see here in my notes. I need to move my mouse over 1 second, guys. Let's see here. I still have my mouse on my other computer. Hopefully that works. Seems legit. Yeah, so we have our notes here from last time. So what did we do last time here? It's been so long because I was at Frosty Faustings last week. I have very little recollection of what the hell we were doing here. So we're aware of 3 different built-in functions in Python. So functions are ways that you can do things in Python, right, or in programming in general. Every program is made up of 2 things, right? You have data, which is information that you're going to be moving around, utilizing, changing, updating, that kind of thing. And then you have operations, right? Data and operations, where operations are what you do with that data. Right? So basically every program's job is to take some data and do something to it. Right? So we're talking about functions here, we're talking about the operations, what you're doing with that data. And we can print data, right? We can use this little print function here to put data on the screen. We can use the input function to get data from the user, right? They can actually tell us their name or whatever they want, right? A number, something like that. We have the int function, which will turn a data type into an integer number. Let's say that you have like a word and you want to treat it like a number. You can use integer. And then you have str, or string, which will take any kind of data and turn it into a string, which is like text. We also have some basic operators. They're not as complex as functions are, but they still are very useful. Like the plus operator will add 2 things together. You can add numbers like 1 and 1 to get 2. You can add 2 strings, which are like text, right? You can add like a hi and there to get hi there. Right? We also have a multiplication, which is a little asterisk that'll multiply numbers. A minus for subtracting numbers. It doesn't work on strings. And equals is the assignment operator. That means that we can give any piece of data a name that we choose and use that name later on instead of that piece of data, which is very useful because it allows us to change that data at some point. And as long as we're still using the same name, then all of our code still works. So it's kind of useful. There's no robot here today. Here goes. Yeah, we're going to be bringing the robot in full-time next week, I think. I'm going to play Mario for 5 hours. Yeah, we already beat it, Dick, so I'm going to be trying to beat it faster. Last time it took us 10 hours to beat it. My hope is that... I'm probably overly optimistic, right? My hope is that tonight I can beat it in 5 hours. Now that I'm going to be going a little bit more focused, I know what I'm doing a little bit more. It's more fresh in my memory. I hope that I can beat it in 5 hours. 120 stars. We're going to see, though. It might take 6 or 7. What's up, Kitty? Welcome aboard, man. Let's see here. We also talked about code blocks, right? So basically, the way the code flows when you write it is from top to bottom. When you start writing your code, you start with the first code you want to run, and then you end on the last code you want to run. Makes sense, right? You kind of give it some instructions line by line, similar to like directions when you're driving, right? It says, you tell your code, turn left, turn right. It's kind of like, give it directions in order, right? You give it its instructions in order. However, you also have code blocks. If you indent some code, then that code will not always run from top to bottom. It'll actually run conditionally. It'll only run under certain circumstances. So typically your code runs, from the first line to the last line. But if some of that code is indented, it might not run at all, or it might run more than once if it's a while loop, right? We know about if code blocks. I think we also learned about else and while. So if and else are like a fork in the road, right? They actually have conditions, and if a certain condition is true, then the if code block will run. And if that condition is false, then the else code block will run. That way you can kind of control what your program does based on what's going on inside of it. And we also have this while loop. The while block will run the code inside the block over and over and over again until the condition for the while is a false. So as long as it's true, it'll keep running over and over again. It's very helpful for things, many, many things, right? Things you want to run forever, more or less. If you could do the cast you could do it. I did it last time, Dix. I can do it first try spot, I bet you tonight. But I'm not going to. I'm not even going to try. I'm going to focus and try and get the stars. Save all of 0 seconds, yeah. I wish you could meet Yoshi up there. So Steve did a PhD study interview. It was all right. What's a PhD study interview? You trying to get a PhD, dude? In cooking up mad burgers? So it doesn't count. Okay. I gotcha. So we also learned about some data types, right? We know about functions. We know about operators. right? We know about code blocks, and we talked before about how every program is made up of data and operations. Well, that data can come in several types, right? We learned about integers, which are whole numbers, like 1 and 2 and 4 and 10. Numbers with no decimal point. We also learned about strings, which are text, like hello there, or hello world, or someone's name, any kind of textual string that's referred to as a string, not only in Python, but in pretty much every programming language. And we learned about booleans, which are a simple data type that represent either true or false. So a boolean doesn't store a number or a string. All it stores is a true or false value. So a boolean, also called a bool, is either true or false. And we learned about floats as well, which are just they're floating point numbers. They're numbers that have a decimal point, basically. We're not going to really fuck around with that too much, even though it's a pretty simple idea. Mostly we're going to be using integers just because they're simpler. So I don't use floats that much in my day-to-day programming life. Unless you're talking about things that are like a 0 to 1 scale, which a lot of things are in programming. Instead of using 1 to 100 or 0 to 100, they often use 0 to 1, in which case you're talking about a float, right? They were interested in the philosophy. Oh, I see. Okay, so you got interviewed by someone who's doing a PhD. Okay, I gotcha. I thought you meant that you got some kind of interview to get into a program for a PhD. And the mod team had surrounding removals. Like the philosophy that you and the mod team had surrounding removals. I gotcha. So some guy was trying to pick your brain and get a paper done. All right, let's look at our let's look at our code, guys. So we had this simple RPG day 1 last time. Let's right-click it and select Edit with Idle, and Edit with Idle 3.7. So last time we used Notepad to edit our program, right? Which you can definitely do if it makes you happy. But Idle is a what they call an IDE. It's an integrated development environment that comes with Python, and really all it is just Notepad, but it has some cool features that make programming a little bit easier. So if you're used to using Notepad, it looks kind of familiar to you, right? It's just a bunch of text. But what's cool about using Idle is that it highlights things based on Python syntax. We talked before about syntax, how every language, including English and Japanese and Spanish, have a syntax. That is to say, the order you put the words in and what type of words they are matter. Right? Any programming language, including Python and Java and C++, whatever, they're all the same way. They have a syntax. The order of the words matter, and the type of word matters. And when you're using an IDE like Idle, which again comes with Python, you can see that some syntax stuff is highlighted for us. So our variable names here on the left are just white. You can see that function names are a different color, and strings are a different color. Kind of useful. Certain code blocks, right? Keywords like while are a different color. If and else are a different color. Right? It makes it a little bit easier to understand what's going on at a glance. And that's why having an IDE is kind of nice. I use Vim personally, but we're going to be using Idle here because Idle comes with Python. And I think not a lot of you guys are going to want to install Vim and learn how to use that. But if you guys have Python already, from the last episode you actually have Idle, go ahead and right-click your Python file from last time. Edit with Idle. Then go ahead and click on the version you want, which comes with the Python. There we go. Another cool thing about Idle is that instead of having to run CMD like last time, the command prompt, the Windows command prompt, we're going to be using this run tab here. Run module. That'll actually run our code for us. It's kind of cool. So it actually saves us the trouble if I open up a CMD prompt. Makes life a little bit easier. Yeah, really, you don't want to use Notepad in the long term. I really wanted to just use that for the first stream to emphasize that programming is not exclusive. Some people that are kind of, they've seen it happen in movies or whatever, they really have no idea what goes on in a programmer's day-to-day life. They might feel like they need a certain program to write code, and you definitely don't. You can just use Notepad. But if you want to get your game a little bit stronger, you can use something like Idle or Vim or something even fancier. But we're going to be using a very simple IDE here. It comes with Python. What's your philosophy? Be a pushover? Get pushed around? There's the only kind of D I care about. MD, obviously. Oh my god, Dex. For example, says Steve, they wanted to know if we thought that giving a reason for removal was useful, or if it ended up making more work for the mod team. Well, I can imagine that's probably not really that useful, but it is probably more ethical. It makes things more sensible to give a reason. Okay, so our code, let's go look through our code real quick before we actually even run it. So we have a few variables here. We're defining a protagonist, right? We have like an RPG here, a very simple RPG. That's a role-playing game. And we have his name for the main character is something that the user inputs. Right? Here we have our input function we talked about before. Now, functions, the way they're called, the way you run them, is by giving the function's name, like input, and then you end it with some parentheses. Right? So when you run a function, you would do it like this. Right? Input. So this is the function itself. Right? This is the function input. But when you want to run that function, you put parentheses on the end. Makes sense, right? Now we're calling that function. Now, when we call input, it puts a little blinking cursor on the screen for the user, and then the user can type in some data they want to input into the program. Then that data is then returned by the function. That is to say that the function spits out some data that we can save using the assignment operator. Right? So if the user types in something here, it will get saved into this name. Right? The name that we decided here. We're calling it protagonist name, this variable name. And then what you can do with a lot of functions is supply an argument. So an argument is data that goes between the parentheses when you're calling the function. And that means you're giving that data to the function for that function to use in some way. In the case of input, if you put in some an argument here, that argument is the prompt that the user gets, right? When they want to, when you want the data from them. So in this case, we're going to be asking the user, "What's your name, son?" And then it's going to save that data and return it right here into this argument we supplied. Excuse me, into this variable name we supplied. And then define some stats, right, for the protagonist. We have his HP as an integer, right, which is 25. And then we have his HP as text. We're going to be using that to print off to the user, right, to show the user what the protagonist's HP is. And we're doing a simple string operation here, a call to the string function. So we talked before about the str function. What that does is it turns data that would otherwise not be a string into a string, right? So we have this protagonist HP, which we defined right here. That's an integer, right? 25. We're turning that, we're turning that into a string, but we're getting a string version of that and saving it as this protagonist HP text. So the integer version still exists, it's right here. But we also have a string version now. We also have his attack power, which is 6. And then we have a Boolean value here. The player is defending. Right? The player is not defending, it's false. He's not defending right now. Yeah, what if there is no reason, Steve? What if you want to ban someone for the fun of it? Or delete a post just because it makes you happy? You guys have the authority to do that? If not, I don't see what the point is of being a moderator. Likewise, we can define the monster's name here. Right? We're going to ask the user, what monster do you face? And we're going to remember that and use that as the monster's name. He also has HP, that's 20. He has his textual HP. Same thing, we used a string function to convert, to copy his HP into a textual form. And then we also have his attack power, which is 3. So he's quite a bit weaker than our protagonist. So our protagonist is going to have a pretty easy victory, it seems like here. Now we're printing off some data for the user. Right? So we talked before about this print function. It's used for showing data to the user. And we're printing off the monster's name, right, which we supplied right here. Then we're adding in a space and then HP. So let's say the monster's name is Dicksucker. It'll say Dicksucker HP and then colon in space. And then his HP in text form. Because you cannot simply add his HP here. Because you cannot add an integer to a string. Right? You can add numbers together, you can add strings together, but you cannot add integers and strings together. So that's why we have this HP text variable here. Okay, we're doing the same thing with the protagonist, right? We're going to say here, Overlord Steve HP, then print off his HP in textual form. And then this last print statement here that has no argument, that just prints off a blank line, just to make it a little bit easier to read. So let's go get this far into our program, shall we? I think it's running right now. Right? So it says, what's your name, son? That happens right here. Right? So this code's working well so far. My name is Vencabot. Right? And what wants to do faith? Well, I'm going to fight K. Reich Jr. Right? I knew this day would come eventually. There we go. So we prints off, Kenny's HP, 20, and prints off my HP. Then it says that Kenny burninated Vencabot. Okay, so I lost 3 health. Now I can choose between attack or defend. So we got a little bit ahead of ourselves, right? So we showed off our starting HP. Then Kenny attacked me, as he often does. And then I lost some health. Now I got to choose what I do on my turn, attack or defend. Well, let's go look at this code, right? What happened here? So we got this far last time, right? We even saw the blank line. Let's go check that blank line out. I'm sure it's really sexy. Right here, right? So we got the HP, right? We got this blank line here. That's from this. That prints off a blank line. But now we have our first block of code. This battle is rigged, says Kenny. Kenny knows. He knows that he can't defeat me. We have this code block, right? We talked before about code blocks. How all the code to this point has run in order from top to bottom. All this code just got done running, right? Because it's flush with the left side of the screen. Once you start indenting code, that means that code will only run under certain circumstances, and it may run even more than once. So let's go look at how this is working now. So now we're in this while loop, right? It says while monster HP is greater than 0 and protagonist HP is greater than 0, colon. So every code block starts with a line that defines a condition and then ends in a colon. That means we're starting a code block here. And you can see that because we're indented. We're indented here. So we're saying as long as the monster is alive and the player is alive, keep on going through all this code until it's not indented anymore. So all this code is within the while block, right? Because down here we stopped indenting. So once the while block eventually ends, that is to say that the monster HP or the protagonist HP gets below 0, then we're going to drop down to here, right? This is our while block. So the first thing we're going to do is we're going to print off monster name, burninated protagonist name. That's actually what happened to us, right? So look at that. Right. I guess we kind of hard to see this. Yeah, so we're seeing here, monster name, burninated protagonist name. That happened right here. K-Reich, burninated Vencabot. Then we're going to say here a simple calculation, right? A calculation says if player is defending. So we have a code block here, right? A very small code block in this case. So it's indented even deeper, right? It's indented past this line. So if the player is defending, then we're going to subtract some health here. We're going to say protagonist HP equals protagonist HP minus the monster's attack divided by 2. So if I have my shield up, I'm taking half damage, right? If the player is defending, then my new HP equals my old HP, whatever it was, 23 or whatever, minus the monster's attack power divided by 2. Else, so this else block runs only if this code block does not get triggered. Right? If and else are like related to each other. So if the player is defending, do this. Otherwise, or you could say, if he's not defending, otherwise, then run this code. My new health equals my old health minus the entire monster's attack power. All right, so if I'm defending, cut it in half. If I'm not, just give me that whole shit. Give me the whole attack power. Then we save our new protagonist HP text form using string. Right, so we're basically replacing our old textual string for my health with a new string that represents my new health, because I lost some health there. Then we're print it off. Vencabot's HP is whatever it is nowadays. Then print a blank line. Okay, that's the monster's turn. This is the monster's turn right here. Now in Python, blank lines are not significant to syntax, so you can put in as many blank lines as you want. Right? I'm using them to divide up the code in a way that's logical for me. As you can see up here, I used a blank line here to divide up the player stats from the monster stats. But again, blank lines are not significant, so you could just have this be right next to each other if you wanted to. If that makes you happier, right? To have it all be crunched together, so it's a little bit more compact for scrolling purposes. Some people do that. But I'm dividing it up here with a blank line to separate the player's stats from the monster's stats, then another blank line for the print statements, for things that are being shown on the screen, then another blank line before the while loop starts. And here we have another blank line right here, right? This is dividing up the monster's turn from my turn, right? That's why I put this blank line here. And it makes it a bit easier for me to read. So we're saying here, if the protagonist is still alive, because the monster just attacked us, right? The monster just attacked. But if I'm still alive, if my HP is greater than 0, then run this code. We have another code block, right? This code block here will only run if my HP is greater than 0. Then we have a player's choice variable we're saving, right? We're saying, hey, listen, we have a player's, we're asking a player for some input, attack or defend, and we're saving whatever they responded with as player's choice. Right? The player's choice now is going to either be attack or defend, hopefully, if I typed it in correctly. If their choice is attack, so equals equals is a different operator from just straight up equals. Equals is the assignment operator. We established that, right? So if we use the equals character, that means that the name on the left, like monster HP, is being assigned the value on the right. So monster HP is now 20, right? Because it's assignment operator, the equal sign. But equals equals is a conditional operator, right? It's kind of like greater than, right? It returns a Boolean. So monster HP greater than 0, that returns a Boolean, true or false, right? And likewise, equals equals means is equivalent to. So if the player's choice is equivalent to the textual string attack, if they typed in attack, then run this code. This returns true or false, right? So if this is true, then run this code. And then otherwise, if the player's choice is defend instead, then run this code. Right, so we have 2 code blocks here. One runs if they typed in attack, and one runs if they typed in defend. So if they typed in attack, then we say a player's defending is false. Right? He's not defending anymore. Right? I'm going to print off, Vencabot slashed K-Reich Jr. with, do I have some more text over here? Yeah, with his sword. Right. Then we have, the monster's HP is recalculated. It's whatever his HP was minus my attack power. Right. So I have 5 attack power, and he had 25 health. Then he's at 20 health now. Right. We subtract my attack power from his HP. Then we save the new string, right, of his health. We use his new health value and get a new textual string out of it using the string function. Then we print off, K-Reich Jr. That's the monster's name. His HP is his new HP. We tell the user what the monster's HP is at. Then we print off a blank line. However, if we're defending, it's different, right? If we're defending, we're going to say here, player's defending is now true. Right? This value is now true. That means that if the monster attacks me next time, it asks right here, right? If player is defending. So we're saying here, yeah, it's true now. I'm defending. That means I'm going to run this code if he attacks me. Use my shield. It says here, protagonist name plus raises his shield. So it's going to print off Vencabot raises his shield, right? And then a blank line. And then we go down here, right? Game over. No, wrong. Wrong, right? Because we're in a while loop still. All this indented code here is in a while loop. So this is the bottom of the while loop. This is as far as it goes to the bottom. But we're going to go right back to the top and then re-ask our question. Is the monster still alive and the protagonist still alive? If they are, then run it all again. Right? And if we hit the bottom, we go back to the top. So we only ask this question here once we reach the bottom and go back to the top. Right? So let's say that the player dies, right here. Right? We don't leave the while loop right now because this becomes false, right? Because the protagonist would be dead at that point. No, we don't leave the while loop yet. We go down here first and ask this question. Then we go down here, jump back to the top. And then this question gets reevaluated. Is the monster still alive and the protagonist still alive? If that's true, then run all this code. If it's false, then don't run it and just drop to the bottom. Drop right down there. So once one of these characters dies, we drop to the bottom, says game over, and then press enter to close. And the reason we have this here is because if you run a Python script by double-clicking it on your desktop, on Windows, it'll bring up a black box with your text. It'll say, what's your name, son, and all this good stuff, and have the fight happen there. But then once the program is finished running, it will just close. It just dies. It vanishes. So that's how it works on Windows. So for that reason, to see the game over screen, we have to put an input here. It'll wait for the user to press enter that way. Right? So we're going to wait for them to put in some kind of input. We're going to say press enter to close. Once I press enter, it'll close the program. So let's demonstrate that. Let's go down here and just double-click this shit. Okay, so it says, what's your name, son? Right, I am, I'll be Dick Sucker. Right, classical 2X Dick Sucker. AKA the real Dick Sucker. And he's going to be fighting Overlord Steve, as he often does. Okay, so Steve attacks Dix right away. Right, so it makes Dix lose 3 health, looks like. I'm going to defend on my first turn. Okay, so Dix raises his shield. So now I took a fractional damage, right? See, my health is a float now because I halved his attack power. Right, I halved the monster's attack power. Okay, so I'm going to attack this time. Okay, so I slash Steve with the sword. Right, so he lost a bunch of health, like a bunch of health. No, he started off at 20, he lost 6 health. Okay, I'm going to attack him again. I don't think he can beat me. Okay, so I still got 14.5 health. He's down to 8. I can kill him in 2 turns, right? Let me attack him one more time. Okay, so he's got 2 health now. I've got 11. I'm going to actually defend, draw the fight out a little bit. Okay, boy, this guy's really, really weak. Steve is pathetic. I'm going to keep on defending, in fact. What can he do to me? Nothing. He's helpless. Right, so I'm going to attack him now. Finish the job. Okay, so yeah, so he perished there. It says game over. Press enter to close. He went to the negative health. That means his health was below 0, right? So when it asked right here, is the monster's health above 0, it became false. So that means that this whole statement here, monster HP greater than 0 and protagonist HP greater than 0, that is not true anymore, right? One of these is not above 0. So we drop here to the bottom, says game over, then we say press enter to close, right? Go ahead and press enter here, and it kills the program. Once the program hits this last line in Windows, once it goes down here, then the window closes. I missed a message from Steve here. He says, I stated that I think it helps, that is, giving them a reason when you delete a post. Beyond giving them a clear, this is what you did that was wrong by our guidelines, I think giving them a reason, even if they object to it, it helps them. Very little eats at people than being told what you did was wrong, and giving them no clue as to what it was. Yeah, don't you want to hurt them? That's what I would do. Right? If they made more work for me, I'd want to confound them and frustrate them and make them wish they'd never been born, perhaps. Maybe even find out where they live using their IP address and send them, mail, like junk mail or threats. Okay, so our code here is very basic. We went through how it works. We only use a few different data types, integers mostly, a couple strings, and then we have that float that results when we do fractional damage. Right? If we do like 2.5 damage, we start looking at float numbers instead of just integers. They have a floating point there. What's up, Austin? It says, what the fuck did I just join? We're doing a simple programming, Austin. It's Intro to Python. We're teaching Python programming. We have a very simple RPG here that's running. And we're going to add to it today, guys. We're going to add to this, make it a little bit more interesting. Right now it's pretty simple. Again, I feel like the hero can't really lose because of the way we balance their stats. But we can actually add new features today. We're going to look at a few things like lists today, I think. Maybe some dictionaries. The two kinds of data types. And functions as well. We're defining our own functions, perhaps. So let's look at our code here. Again, it's very simple, but functional, right? I wish they'd never been born. Yeah, we're talking about my friend Overlord Steve. He's a moderator on Reddit, and he was mentioning that he thinks that he can help users by telling them what they did wrong to have their message removed from the board. And I was pointing out that maybe you don't want them to know. Maybe you want to hurt them for making more work for you. Okay, so what kind of new feature do we want to add today? Well, let's look at this real quick. I think, well, let's solve a bug, first of all. We have a bug in our code, right? It's right here, right? The player's choice is the result of an input from the user, attack or defend, right? If they typed in attack, this code runs. If it was a defend, then this code runs, right? But I can type in anything. Let's go back to our code where I'm fighting Kenny, right here. Right? I can attack him. Right? I can defend against him with my sword, with my shield. But I can also, jump up and down. What happens then? Okay, well, nothing happened. He just attacked me. Right? I didn't get my turn. I lost my turn. I typed in the wrong thing. Why is that? Well, because we have no code here for dealing with if the user types in some bullshit, right? We run this code if they typed in attack, and we run this code if they typed in defend. But if they typed in neither one, then nothing happens, right? We just skip all this and go right back to the top again. So here's what we're going to do, guys. We're going to use an else statement here. I'm going to show you guys what I'm going to do here. Okay, watch. Okay. So we're still going to lose our turn. But we got a little error message now. Here's how it works, right? Here's how it works. So we're saying, if the player typed in attack, then run this code. Otherwise, else, right? If else. So if it was an attack, well then, if it's defend, then run this code. Otherwise, right? Else. Tell them you have to either attack or defend, and then print a blank line. Right, so now we're saying, if it was attack, then do this. Otherwise, if it was defend, then do this. Otherwise, if it was not attack or defend, right, because we're inside this else loop, we know it wasn't attack, because we're already inside this loop, right, it's in this block. We're already in this block, so we know it's not attack. But if it's not defend, then print off, you have to either attack or defend. Right? So let's see what happens here. Run the manual. Run that manual. My name is going to be Seraph. Right? And the monster is going to be Austin. Right here, the two sides of his personality here going to war. So now I can attack, sure. I can defend. Right? I can raise my shield. But I can also, if I try to jump up and down this time, then it says here, you have to either defend or attack, right? So we have this error message now that occurs if it's not what we expect to get. So that's kind of solves our problem a little bit. However, we still have this problem where we lose our turn. We still lost our turn for that. Well, how can we solve that problem? Well, we got to find a way to re-trigger our turn. But the problem is it's not that simple, because the monster's turn and the protagonist's turn are in order. So once we hit the bottom, it re-triggers the while loop, right? We go back to the top and then start from scratch and get the monster turn again. Well, one way to solve it that would make sense, we give the player the first turn, right? That way we could just go back to the top of the loop using a statement called continue. I'm going to show you guys. Let's demonstrate that, shall we? Let's just change the order of the turns. Let's give the player the first turn. That's one way to solve our problem here. All right, let's go down here, paste that code. Okay. Right, so now we have a different kind of layout here. So, in fact, now we know the protagonist is going to always have health, right? We have to change this now. We have to change it so that it says here, if we got it to the top of the while loop, right? Because the while loop only runs if both the monster and the player are alive, correct? So we know the player has health. So we can get rid of this line. And then we can unindent all these lines. Oops, I know that would do that. Okay, so it's 1, 2, 3, 4, 1, 2, 3, 4. Oops. But now because the monster has a second turn, right, instead of the first turn, that means we have to ask if he's alive or not. Because he might be dead by now. He might be dead when the player attacked him. So if monster HP is greater than 0, then he gets a turn. Then and only then does he get a turn, right? Alright, so now our program should work exactly the same. It's just that now we get the first turn. So let's go and demonstrate that real quick. Run the module. What's your name, son? This time I'm going to be, Wars. Our friend Wars. And the monster is going to be, Jeefy Beefy. Because we haven't seen him in a while, so we can villainize him. We can vilify this dude now. Why does Task Manager use the phrase, kill the application? Because they're all executable. Wow, Steve. Holy shit. Holy shit. Now, if you had come up with that yourself, I'd give you 10,000 points. But I feel like you probably just found that somewhere. So yeah, so now we get the first turn, right? Before, the monster always got the first turn. Now we do. Attack or defend. Well, I can attack him. Our advantage is getting stronger, right? We already have more health and more attack power than the monster does. But we also get the first turn now? Yo, it's just so one-sided. Right, so we can defend. We can just go ahead and keep on doing this. We'll let him kill us this time. We'll throw him a bone here, this monster. Let's defend until we die. Let's try to, run away. Oh no, we have to either attack or defend. Fuck. Alright, let's try to attack then. Okay, now let's run away. No! Okay, so we just died. Right, we just died. That sucks. Oh well, I'll get over it. Steve says, well, sadly, no, but it's mine now. That's terrible. That's absolutely terrible. So, we still lose our turn, right? We tried to run away. It doesn't work. We lost our turn. But we can fix that because now we have the first turn. So we can use this statement in Python called continue. Right? Like this. Continue. So what continue does is it says, don't even finish your current loop. Just jump to the top of it. That'll work in a while loop and other kinds of loops we're going to learn later. So by putting continue here, we're saying if they typed in the wrong shit, right? If they typed in the wrong shit, then just jump back to the top. Don't even go down any further in this loop. Just go right back to the top. So that means we're going to get our turn back. Watch. Okay, my name is going to be, David. I know. Kind of out there. Kind of an out there idea. Monster is going to be, I don't know, what's a good name? Like, how about David's X? Right. There you go. So David's X has some amount of HP, so do I. Now we can try to run away. And it'll say you have to either attack or defend. Now it says attack or defend. Right? So actually the monster did not get a turn this time. Why is that? Because we use this continue statement here. Right, let's go adjust our notes. Where's our notes at? Oh, it's so bright. That is so bright. Right, so we're gonna go down here to the bottom. We're gonna say here, it's day 2 of Intro to Python, Season 3. Right, Season 1 was Pokemon, Season 2 was a text-based adventure game. Now we're doing like a classical RPG, like a one-player RPG. The first new thing we're learning today is about special statements, in Python that affect the flow of loops, right? Flow of loops. Continue will cause the program flow to jump back to the top of a loop without needing to reach the bottom first. Right? That's what we learned. Let's go review that one more time. So we talked about how the way this while loop works is that it runs the whole loop, hits the bottom where it stops being indented, right? And then goes back to the top and then re-asks this question. Right? If that question is still true, then it runs the loop again. And so on and so forth indefinitely until this becomes false, right? But by using continue here, it says if this line of code runs, it says continue, then just jump right back to the top and ask the question again. Right? Ask this question again. If it's still true, it rereads it, right, etc. And this continue will only run if the player types in some bullshit. Right? If they attack, then this code here runs, and this else block does not run, right? Because if else, only one can run. If this first one runs, the second one does it, and vice versa. So if they type in attack, this code runs, then this code gets skipped, and then this code runs, right? But if they did not type in attack, then this code runs, and then this code runs, unless we trigger this else block right here, because it says continue, right? That means this code won't run. It'll just jump right back to the top again. So program flow is a kind of a big deal. It's kind of a big deal. I think from what I found from doing this Intro to Python series, that's one of the harder things for novices to understand is program flow. Right? I kind of took that for granted that it was something I've grown up with, so it's kind of easy for me to understand. But for novices that have never programmed before in their lives, it's kind of weird. So I'm going to go through it one more time, guys. Up here, any code that is not indented is not inside of a block. And that code will always run top to bottom. So all this code here happens in order. We get asked for a name, then we define some attributes. Then we get asked for another name, and we define some attributes. Then we print off some data onto the screen for the user, our current HP. Then we trigger this while loop. Right, that happens next. But because this code is indented, any code that's indented is inside of a block, and that may or may not run. Right? So all this code is definitely going to run, because it's not inside of any kind of code block, and it runs top to bottom. But code inside this while loop will only run if this statement is true, and then it will keep on running until that statement is false, right? So all this code gets run to the bottom, and then it goes back to the top and asks that same question again. Is this still true? If so, then it runs it all over again. We also have if-else blocks, right? So these blocks define a condition, like if the player's choice is attack. And then it'll run this code, this indented code here, this block, if that's true. And then the else block that follows will only run if that code up there did not run. It's a fork in the road. Right? If you define an if without an else, like you can do that no problem, right? You can define that and do that right like this, right? We can just say, if, player, we can define something. We're going to say if protagonist HP is greater than 0, if they're still alive, print off, protagonist name plus is victorious. Right? So if at the end of the loop, if the protagonist is still alive, then print off that he's victorious. Right? But if the monster survived, then this code will not run. but there won't be a message yet to tell the monster he's victorious. Right? But that just means that if you have an if block with no else block, it just means it won't run if it's false. This won't run. No big deal. This will only run if that's true. But if there's an else block on there, like this, that's attached, that means we can make a fork in the road. So if this runs, great. If that doesn't run, then run this code. We're going to say, monster name plus has slain plus the protagonist name. Right, and we're going to say plus a period, like that. So now we have a fork, right? We're going to say, if the player's still alive, then congratulate them. But if they're not alive, that means the monster is the one that killed him, right? So we're going to say the monster name is slain so-and-so. Because we know we only got this far. Right? We only got this far if we broke out of the while loop. That means that one of those two guys is dead. And we know it can't be both of them, because if the monster is already dead, he don't get a turn, right? He can't kill our player after we've killed him. So we know that only one of them is dead. If it's not the player, then that means that the monster is dead. Okay, then it says game over, press enter to close, right? So we have this new little if block at the end, if else block. That's all well and good. Now down here, we use multiple stacked, or nested, they're called, like nested, if statements, right? We're saying here, if the player entered attack, then run the attack code. Otherwise, else, right, if they did not put in attack, then we're going to say another if block, right? We're going to say, well, okay, we know that they didn't type in attack. Because if we're down here, they did not type in attack. Because that would have ran otherwise, and we would be out of here already. So we're going to ask another question. Well, did the player type in defend? If so, then run this code. And if we enter this else block down here, we know that it was neither attack or defend. So we're going to say, listen, you got to attack, you got to do one or the other, right? You got to do one or the other. Then we continue, go back to the top of the loop, get the player's turn back. But we're getting pretty deeply indented here at this point. Like, we're nesting a lot of shit. We could do the same thing if we had, let's say we had like a magic command, or use an item command. There's going to be a lot of indenting. Or you can say down here, like, if the player's choice is defend, then do this. We're going to say else if player's choice is, magic. Right, we'll say use item. Let's just say item. Right? If the player's choice is item, then print off that's not implemented yet. We're going to do that by the end of today, I think. Right, we're going to print off a blank line, then continue, give them their turn back, because we don't have that item worked out yet. We're going to go say here, attack, defend, or item now. Right, and we're going to say here, else, you have to either attack, defend, or item, right? There you go. So we have this nesting of commands, basically, these nesting blocks. They're going to be nesting indefinitely until we have all of our commands worked out, right? And we're getting pretty deeply into. Look at this line right here. It's only actually beyond the edge of our screen, because we're getting so deeply indented. Well, how can we solve this problem? Well, thankfully, Python includes a code block type called elif, and elif is just an else block immediately followed by an if block, and it saves us some indenting, right? So here we're saying else if, right? Else if player choice is defend, else if player choice is item. Well, instead of doing that, let's just say elif. Same thing. So I can just backspace through this. Right there. Elif. Elif player choice is defend. So we're going to say if player choice is attack, then run this. Else if player's choice is defend, then run this. Elif player's choice is item, then run this. So that saves us a lot of indenting, right? Now our code is much more readable. Then we can say else at the very end. So we've learned about a new kind of code block. So we knew about if code blocks, we knew about else code blocks, we knew about while code blocks. Now we have this elif code block. Elif is sort of like a second if, basically, right? Saying if the first if did not trigger, then how about this, right? And if that one didn't trigger, then how about this? And if none of the above triggered, we have this else block, right? If none of the above triggered, then do this. So that makes our code much less deeply indented, much easier to read, and it's very important type of code block. Let's run this code now. See if it works at all. Run the module. Okay, my name's going to be, I don't know, Sassafras. Pretty good hero name, I feel like. And the villain's going to be, Cotton Candy. Pretty cool name for a dragon, I feel like. Okay, we're going to say, I want to do runaway. Okay, so you have to either attack, defend, or item. Okay, and then it gives me my turn back. Because we hit this continue statement, right? Right here. So instead of giving the monster a turn, we jump back to the top of the loop, where we get our turn. Okay, so I want to try an item. Okay, it says that's not implemented yet. Then it gives me my turn back again. That's because we triggered this block. Right here. Print, that's not implemented yet. Print a blank line. Then continue. Go back to the top again, give me my turn again. Okay, let's try attack. It still works the same as ever, right? We still attacked the enemy, and he lost HP. He attacked us, we lost HP. We can defend to mitigate the damage for the next turn. Pretty basic stuff. But, it's a game. Right? Even though it's very basic, it's something we can learn in, a night and a half. We have our first game running. It's kind of cool, right? It's kind of real cool. But now, why don't we look at a new kind of data type? Let's make an item, right? Let's make an item. So, what's a good item, Austin? Like a grenade? What's going to damage our opponent that we can throw at them? What do you guys think? We can actually have more than one. Let's have more than one. What do you guys think we should throw at our opponent? It's going to hurt them. We're going to have a player inventory, right? We're going to do like this. You guys don't know what that means yet, but that's what we're going to be doing there. What's good for throwing at our opponent? Grenades are good. Fire bombs. Rocks. Other heavy objects. If I was going to throw something at Kenny to damage him, I would probably choose like a spear. That's what I would do. I think spear works pretty well. Okay. So I'm going to put a spear, right, in my inventory. So here, let me actually go to our notes first and enter this elif block. Right. I also learned about a new code block type called elif. Elif blocks define a new condition to test for after an if block. That will only be tested for if the previous if didn't trigger. It's basically an else followed immediately by another if. Right. So we have the spear now. We have a new data type, right? Let's go. I'm going to make some more notes here. We're introducing a new data type. We've learned about numbers, integers and floats. And we've learned about textual strings. And we've even, learned about booleans, or bools. But we're going to also talk about lists. This is a new data type for us. So, a list is a collection of other data types. They're stored in order. And you can search through a list and run certain code blocks only if you find what you're looking for. Okay. So that's not Vim. So So what does that mean? Well, let's see here. We have this a new variable, right? Player inventory. Right? And I'm putting a spear in there. So when you have a list, you define that list by enclosing all of your data inside of it in these square brackets. Or these square brackets, right? So when we have a square brackets like these, we have an empty list. It's still a list, it's just empty. But we can put data in here, such as a spear. Or we can even add more by putting a comma, right, and then a space. We can say we put a spear in there. How about also, what else is good for a spear? A roll of toilet paper. Good for throwing at the opponent. So now we have a list of 2 strings. Right, we have 2 strings in our list. One is the word spear, and one is the string a roll of toilet paper. That's what we have in our inventory right now. The latter of which has several uses. Cool. So how do we use this list? Well, we have this item command, right? That's not implemented yet. Well, I think that the player wants to use an item. We should tell them what they have, and then have them type in what they want to use. Right? So if they type an item, we can say, you have spear and a roll of toilet paper. In fact, let's call this a spear, right? Because it's a roll of toilet paper. Let's make it all even. So we have a spear. Well, now let's actually get rid of the A altogether. Let's just use it like this. Spear and roll of toilet paper. Right. So, if they type in the word item, I want to tell them what they have. So let's say, you know, instead of that's not implemented, let's say you have, and then we're going to put in another line, print, you know, 1, 2, 3, 4. You have spear, and you have roll, oops, I'm sorry, roll of toilet paper. Then we ask for an input, right? We're going to say input, we're going to say, you know, used item, we're going to make a new variable here. Used item equals input, what the player's typing in. The prompt's going to be, which do you want to use? Right. So we got the input. We're going to say here, you know, we're going to say print off for now. You know, can't do that yet. So to enter what I want to use, we're going to save it, but we can't do anything about that yet. Print a blank line. Let's see what happens here now. Let's run this code. Oops. Let's go save it and run it. Okay, what's my name, son? I'm going to be, who else is cool to be? Maybe, you know, Lucky the Leprechaun from Lucky Charms. We'll be fighting Tony the Tiger. Okay, so, we can attack him, sure. Right. But let's try and use an item. Okay, it says you have spear and a roll of toilet paper. What do you want to use? I want to use the spear. I can't do that yet. Okay, so that works more or less. But here's our problem, right? Let's say that we didn't have a spear. Oh, let's not get there yet. Let's say used item, right? We have this input, right? Let's actually utilize this input we just got. We're going to say here, if used item is equivalent to spear. Right. Then we're going to say here, print. Let's subtract the monster's health first. So we're going to say here, monster HP equals his old health minus the HP is going to be protagonist attack times 2. So the spear doubles my attack power when I use it. It's a pretty badass spear. Okay. Then we're going to print off here. We'll get his text version too. Monster HP text equals the string version of his HP. Okay, we're going to print off, you know, protagonist name plus hurled a badass spear at plus monster name plus exclamation mark. So this badass spear now. We're going to print off a blank line. We'll print off his new HP, right? print off monster name plus HP plus his HP as a string, as text, and then print off a blank line. Right. So if they type in spear, then do that. We're gonna say otherwise, you know, elif used item equals roll of toilet paper. Then just print off protagonist name plus hurled a roll of toilet paper at the monster name. You know, it wasn't very effective. And then print off another blank line, and there you go. That's that turn. All right, so we're going to say, you know, else. If they typed in something else aside from that, we're going to say print protagonist name plus isn't carrying that, right? They didn't type in one or the other. We know he doesn't have the item, right? There you go. Then we're gonna give him his turn back. Okay. Cool. So we changed the way that the item command works. Right, let's go review our commands we have now for our player. The player can either attack, where it simply reduces the monster's health by the player's attack power, and reports how much health the monster has. We can also defend, which will change this flag. Right, the player's defending a flag is changed to the Boolean value of true, and that means that now the players will take half damage on the next turn the monster gets. And we can also choose an item. Right, if we choose an item, it'll print off that we have a spear and a roll of toilet paper. Right, and it'll ask us which we want to use. We can use either the spear, where it'll reduce the monster's health by double damage, and print off some data. And then we use the TP, which does nothing. Otherwise, we typed in some other kind of data, like let's say we typed in, I don't know, potion. It says we're not carrying that, and then returns us back to our turn start. Get our turn back again. Let's see how this works now. Okay. So let's run our program here. I'm going to actually run it again. My name is going to be, this time, why don't we be, you know, Batman. And the monster's going to be Spider-Man. All right, fuck Spider-Man. Batman forever. So I'm going to say I want to use an item now. Okay, I want to use a potion. Okay, it says Batman isn't carrying that. Okay, so attack, defender, item. I want to use an item. I want to use the spear. Okay, so Batman hurled a badass spear at Spider-Man. Okay, he lost a lot of health for that. Lost double damage. Okay, I also want to use a roll of toilet paper, right? Roll. I want to use item. I want to use roll of toilet paper. Okay, so Batman hurled a roll of TP at Spider-Man. It wasn't very effective, so he didn't lose any health, right? But we have a problem now, guys. That code works great. It's awesome. Add some more variety to our gameplay. But we can also reuse the spear. I want to use an item. I want to use a spear. Okay, so he died. I threw a spear at him and he died. But here's my problem, guys. If you look at my inventory, I have a spear and a roll of TP, but I already threw my spear. Right? So that's kind of a problem. Well, the problem here is that all this code down here for the item usages is hard-coded in. It's not really referencing my inventory at all, right? It's just telling me we have a spear and a roll of TP, and you know, if they use a certain command, we can run this certain bit of code, right? Kind of like our other commands. But now I want to actually utilize our list in some way, our list data type. And that's kind of cool because Python and other languages as well really can become very creative once you utilize lists effectively. So we have this list that has two strings in it, right? Well, instead of printing off, you know, these hard-coded values, let's say I want to add an item, right? I want to add a potion. Let's go to our list and add a potion. Right. Cool. So we have 3 items now. But this still only shows 2. Right? Well, what I could do is I could, you know, punch in print, you know, we have a potion now. But the problem with that is if I used a potion, this still prints that off as me having a potion. So instead, we're going to use a new code block called for. Right? It's a new kind of looping block. You know, that's kind of cool. We like while loops. While loops are very powerful. Right? This while loop we're in gives us an entire game out of only these few lines of code because it runs over and over again. Right? Well, for is another looping type, also very powerful. Let's say it prints off you have, right? I'm going to say for item name in player inventory print 1, 2, 3, 4 plus item name. So So how does this for block work, right? This new kind of block. We have if, we have else, we have elif, we have while. Now we have this for block. Right? It's indented code here to tell us it's a block. Well, the way that for works is that it takes every item or every value inside of a list, and it gives it a name. So, for instance, we have 3 values, right? We have spear, a roll of toilet paper, and potion. And we're saying for every item in that list, I'm going to give it this name, item name, that variable name, and then do this thing to it. Right? Kind of cool. So we're saying that for every item in the list, print off 4 spaces, and then that item name. And it goes through every item in that list and does that to it, basically. So let's go see what happens here. Let me run this code. You guys probably already know, right? Let's just go demonstrate it anyway. My name is going to be, Lucius. It's a sick, and I'm going to be Luscious, actually. Luscious. My opponent is going to be Fugly. I want to use an item. Okay, so now it says you have spear, a roll of TP, and potion. So what it's doing here is for every item inside my list of inventory, it's printing off 4 blank spaces, and then that value in the list. That does that for every item in the list, right? So every item we add, I can actually add more items. I'll just add in, we can add in another item just to prove this works. How about like a thumb drive, right? A thumb drive. Then rerun our code. Okay, my name's going to be, we're going to give Lucius a second chance here. Luscious. And Fugly gets a second shot too. I'm going to use item. So now I have a spear, a roll of TP, a potion, and a thumb drive. Right? So for every item in that list, it's running this block of code. It's a loop. Right? It's kind of like while. While will run as long as its condition is true. And for will run for every item inside that list. Right? So for item name, we can call this whatever we call this, for our item, we call it whatever, right? We could choose that name. So for this variable in this list, right? So for every item in that list, call it this, and then do this thing to that item in that list. So we're gonna print it off. Right? So I say, what do you want to use? Okay, cool. We can use spear. We can use roll of TP. We can use we say elif. Used item is a potion. We can say pass. You guys know about pass, right? I'll explain that again in a second here. Elif used item is thumb drive. Then do this pass for now. Pass just means don't do anything. Now, of course, if we were up here, right, up here, and didn't want to do anything for a line, that's easy. Just fucking put an empty line, right? Don't do anything. But the reason we use pass is because in this case down here, we have this code block, right? As you can see, right, this code block. Elif ends in a colon. We need to indent something for it to be syntactically correct in Python. If we had nothing here, we would have no indented line, and that would be a syntax error. That means that every time you have a code block, it has to have something indented. So pass just means don't do anything, and it still indents the line. So that doesn't do a jack shit for now. Coolio. So we have another problem though, right? Even though we have our inventory being printed off for us here, we can still use indefinite numbers of spears. Right? How about we even let me actually demonstrate another bug here. Get another bug. Let's take the potion out of the inventory. Let's take the spear out of the inventory, right? Take the spear away. Oops. Cool. Let's run our code now. See what happens. I'm going to demonstrate a bug to you guys. My name is going to be Luscious. That's my real name. Fugly. I'm going to use an item, right? It says I have a roll of TP, a potion, and a thumb drive. That makes sense because our inventory up here only has those items in it. We took away our spear. And this list here is this visual list is being generated by that for loop. So we have no spear, but I can still use my spear. But I hurled a badass spear at Fugly. Why is that? Because it's very simple. Down here it just says, if what I entered in was the word spear, then run this code. Right? Very, very simple. But we can use a new kind of condition, right? Based on a list type. Watch this. If spear in player inventory, then run this code. Okay, so we talked before about conditional statements, right? Such as, if the player's HP is greater than 0, that's like a test for numbers. We can test the numbers. We can say, if player's choice is equivalent to attack, that's a test for strings. We can find out if the strings are, the same. But now we can do conditional tests for lists. We can say, hey, if this string is a value in this list, true or false, then run this code if true. So only run this code if the player has a spear in their inventory. So we can go up here, we can say, else print protagonist name plus doesn't have a badass spear. And then we're going to print a blank line, then continue. Okay? So now this code will only run if the player has a spear. Let's go try this now. My name is going to be, Candy. And my monster name is going to be, something like Porsche. What good stripper names. Okay, so I want to use an item. And I want to use my spear. As you can see, I only have a roll of TP. I have a potion of thumb drive. I want to use a spear. So Candy doesn't have a badass spear. Okay, so spear was not in player inventory. Right, because this code got triggered right here. So what if we put a spear in the inventory now? Go up here and add the spear. Okay. Let's try this again. Okay, I don't think I want to be Porsche this time. My opponent will be, what's a good stripper name? How about, I don't know. What's a good name? What's the name of one of my exes? How about Stephanie? Okay, so, I want to use item, right? I want to use now I have a spear, right? If I try to type in spear here now, it's going to run this test. Let's go down here. It's going to say here, I want to use an item. If I type in the word spear, it's going to say, if spear is in player inventory, then use the spear. Otherwise, print off, I don't have a spear. Well, now I do have a spear in player inventory. Right? So that code should work now. Let's see if I can use a spear. Enter. Hey, it worked. I threw my spear, but I still have a problem. If I go to item and then use a spear again, I can still use it over and over again. Right? But hey, at least now we have this test to see if I have it or not. Now, all we got to do is we can use the remove method of this list. Watch. I'm going to use the spear, right? So I threw my spear. Right? I'm going to, once I've done printing all this data off, I'm going to say here, player inventory dot remove spear. I think that works. I might be wrong about that. Let's go double check that. Run the module. My name is going to be, how about, Chowder. And my monster name is going to be Flapjack. So I'm going to use an item, right? I have a spear, it says. I'm going to use my spear. Boom. Now I'm going to use another item. Oh, look, I lost my spear. Let's try and use the spear again. I don't even have a spear. So now we've actually have an inventory that gets updated as we use items. Let's go see why that would be, how that works. Well, we start off with these items in our inventory. A spear, a roll of TP, a potion, and a thumb drive. Right? It's kind of a lot of code. We should actually condense our code a little bit here soon. This code's getting pretty long and noodle-ish. Especially the player's turn. Yeah, so we're saying here, when we use the item command, we are printing off the items that we have, using this for loop. Right? The for loop goes through every item we have and lets us know we have it. Then we get to choose what we want to use. And if we try and use a spear, the first thing it says is, hey, do you even have a spear? Right? If the string spear is in this list, then run this code. If they don't have a spear, then let them know they don't have a spear, and then go back to the top and ask them what they want to do on their turn again. Right? But the cool line here is this line right here, player inventory.remove. I think, to my knowledge, this is the first time we've used a method. So we learned about functions, right? Functions are called when you give the function name, like print or remove, and you call it by putting parentheses on the end. And between those parentheses, you supply an argument, which is tells the function how to do its job. Right? Think of the follow nerd ray. It's kind of a cool name. Welcome aboard, man. I'm David. We do programming here at least on Fridays. It's our intro to Python day. We're teaching Python, very basic type stuff for total beginners. If you're an intermediate programmer, it might be a little bit under your level. If you're totally new, though, welcome aboard. Feel free to ask any questions you have. So functions are called by giving their name and then calling with parentheses. Between those parentheses, you have an argument, potentially sometimes. And that argument is given to the function to help it do its job. So we have this remove function. And we're giving it an item in that list to take out of the list. Right? Spear. But it's not just a function, it's actually a method. A method is a special kind of function. A method is a function that's attached to some piece of data. So we have this list, the player inventory, dot remove. What's crazy about methods is that they have access to the object they're attached to. So by calling player inventory dot remove, even though we're not supplying the player inventory as an argument, we actually remove actually has access to that inventory because it's attached to it. So we're saying don't just use the remove function. There is no remove function. Use the remove method that is attached to this list. And every list has this remove method. So when you call this little period here, the period is the Python's equivalent of an apostrophe S in English. It implies ownership. So we're saying use the player inventory's remove method. Right? But in Python, you don't use apostrophe S. In English, you do. In Python, you use a period. So use the player inventory's remove method and remove this item from that list. That's kind of how that works. Thanks for the info. PowerShell programmer looking into Python this year. Always good to see it as a basic coder first. Yeah, Python is a beautiful language, man, in more ways than one. It's very powerful. It can do anything you want to do. It's as capable as C++ or Java or any fully fledged language. But what's cool about it is that its syntax is very simple compared to other languages. It's got a very nice, very clean readability to it. But it's also interpreted. I think it's great for beginners because you don't have to compile anything. You just run it. It's pretty dope. Okay, so now we can do the same thing for these other items, right? Like toilet paper. Let's say, if roll of toilet paper is in the player's inventory, so if they have this TP at all, then and only then use the TP. And then remove it from the inventory. If they used it, it's gone. Then we're going to say else print off, protagonist name plus doesn't have a roll of toilet paper. Probably, let's print off another line here. Print. Probably going to need to do something about that later. Print a blank line, and then go back to the top of the while loop, right? Get the player's turn back. Okay, so now we can use up our spear. We can use up our TP. Right? Why don't we do the same thing for these potions? Right, let's give this potion a cool feature. Let's say here, we'll say if potion is in player inventory, if they have the potion, then let's say player HP equals player HP plus 10 to restore 10 health, basically. Right? Then we're going to say it's actually protagonist, right? Protagonist HP. We're going to say protagonist HP text equals string version of the protagonist HP. There you go. We're going to print off a little string for the player to read. We're going to say protagonist name plus chugs a delicious potion. It's just mad tasty. we're going to print off his new health, right? Protagonist name plus HP plus the protagonist HP, the text version of it, right? Print off a blank line, and then we're going to say player inventory dot remove the potion. So they have a potion now, they can use it up. It's gone now. If they don't have a potion at all, right? This code only runs if they have the potion in their inventory. If they don't have it, say print protagonist. I'm sorry, I don't want to have it to be a string, but to be a value. Protagonist name plus doesn't have a potion. Print sad face. Like that, right? And then print a blank line, and then continue, right? Give them another turn. They've typed in something they didn't even have. Should be reading says, so are there namespaces? How are class and project structured for object-oriented development? Yes, should be reading. There is namespaces in Python. You can use that by, the way namespacing works is the module name. We're not that far. This is a beginner's course here. We're on our second day of this season, which means we're still in some very basic. We haven't even talked about modules yet at all. But just for your information, as you asked, yeah, if you import a library, let's say, import time, right? The time library has a function called sleep in it, but we can make our own function called, we can make our own value called sleep, right? Like, sleep equals, is great, because sleep is fucking great. But if you want to use the sleep from the time module library, you can call it as, time.sleep, right? Is some amount of seconds, right? Like 2 seconds, basically, right? So basically, the way namespacing works is when you import a module, you can choose to leave its methods, its functions, its attributes, its variables under that namespace, time.sleep. You can also, from time, import, sleep. And then that would actually be called just sleep, in which case you cannot have your own value called sleep. That would overwrite it. If I define sleep right here, then sleep would no longer work in that case. Right? That's why I prefer to just kind of leave the namespaces intact by just saying import time. And then you could use time.sleep. That way we know which namespace sleep we want. That's how namespacing works here in Python. But we're not that far yet. We're not talking about libraries yet. Let's go. Welcome aboard, dude. Yeah, namespacing is great. I think in Python, Python culture, a lot of guys really do lean toward from module import something, in which case you lose the namespace. That really kind of rubs me the wrong way personally. I love namespaces. But some guys in Python really are more about that, keeping everything in the same namespace, which is fine if that's what you're into. By all means. Okay, so we have this potion out, restore some health. We have a thumb drive as well. Let's just, we're going to say, whether or not they have it or not, we're just going to print off, no one can ever know what's on this drive. And then we're going to just print off a blank line, and then we're going to continue. Right, so in this case, we're not even asking if they have one or not. It doesn't really matter. The thumb drive has no use yet, so we'll just have that be a thing. Okay, so now we have an inventory that has 4 items in it, 3 of which are useful. The spear, the TP, and only 2 of which are useful, the spear and the potion. But the 3 of which get consumed upon use. Right? When they're used, we remove them from that list. Remove the spear. Remove the toilet paper. Remove the potion. Right? Once they get used up. And then before they're used, we ask, if you typed in that, that item name, we ask, well, do you have it? Right? If the role of TP is in the player inventory, then you can use it. Otherwise, you can't even use it. Right? So now we actually have a real functional RPG inventory with items that are of limited usage. Right? Let's go here to our program and run it. Okay, so we can put a name in here. It will be Nerd Raids. Right? He's going to be fighting should be reading because they're eternal rivals. Okay, so we get our first turn here, right? Let's go ahead and just attack. So Nerd Raise / should be reading with this sword. So should be reading lost some health. Then should be reading burninated Nerd Raise. So I got lit on fire. There's no period. Let's add a period there, right? Look, we have a sentence here with no period on the end. Let's go see why that would be. Go down to the monster's turn, right down here. We say here, a monster name plus burninated plus protagonist name plus exclamation mark. There we go. Now we're talking. Let's go back to our fight here and finish it up. Okay, so now we can attack, defend, or item. Let's use an item this time. So it prints off all the items we have, right? It goes through every item in this list using this for loop right here. So we say we want to use an item, right? If the player's choice is item, it says print off, you have, and then for every item in that list, call it our item and do this thing to it. Right? So it loops through every item. It says print off 4 blank spaces and then our item. So let's go see how that looks. It says you have, it prints off spear, roll of toilet paper, a potion, and a thumb drive. It says wipe his ass. Let's go. Let's use a roll of toilet paper. Actually, let's use something I don't have yet, right? Let's just use our imagination. We don't have that yet. It says Nerd Race isn't carrying that. We'll get our turn back. So why is that? Let's go back here to our turn here. So if we typed in item, right? If we typed in item, then all this code gets evaluated. Right? It says here, if we wanted to use a spear, do this. If we wanted to use a roll of TP, do that. Otherwise, we want to use a potion, then do this. If it's a thumb drive, do this. Then it says here, else. If it was something we didn't even carry, right? If something we don't even have, or something we don't have a command for yet, print off, we're not carrying that. Then just continue. Right? So that's why that happened, right? It says, I'm not carrying that. Let's try and use an item we actually have. Let's use a roll of toilet paper. It says, Nerd Race hurled a roll of toilet paper at should be reading. It wasn't very effective. Should be reading burninated Nerd Race. Okay, Nerd Race lost some health there. Let's go see what happened there. So we used a roll of TP. We typed in a roll of toilet paper right here, right? So used item is actually something that player typed in right here. Used item equals the return value of this input. What do you want to use? Right, so whatever they typed in gets saved here as used item. It says, hey, if we typed in spear, do this. If it was a roll of TP, and it was in this case. First we said, do you even have it? And we did actually have it. It says protagonist name, hurled a roll of toilet paper at so-and-so. Right? It was not very effective. Blank line. Then player inventory.remove a roll of toilet paper. We shouldn't even have it anymore, right? We actually removed that from the inventory. So when you have a list object, like our player inventory, we define that up here, right? It's a list. It's got these square brackets on the left and right, and between the square brackets is a comma-separated list of objects to put inside that list. In this case, they're all strings. They're all textual strings. We have a spear, a roll of TP, potion, and thumb drive. Right? That's our list there, the list of strings. And we're saying down here, use that list's remove method. Right? The remove feature on it, the remove functions attached to it, aka a method, and then remove the item from that list that has this value. It's a string, a roll of toilet paper. So that's supposed to remove that from the list. Let's see what happens. Let's go back to our fight. I want to use the item again. Okay, so I only have a spear, a potion, and a thumb drive. Right? Because we've removed the roll of TP last time. Let's try and use it now. Roll of toilet paper. It says Nervous doesn't have a roll of toilet paper. Probably gonna have to do something about that later. Yeah, so we don't have a roll of TP anymore. And let's go back to our item, and I want to use the spear this time. Okay, so Nerd Race hurled a badass spear at should be reading. He lost a lot of health. He only has 2 health left. I'm looking pretty good. Should be reading a burninated Nerd Race. He's got 16 health. So we're looking pretty good here. Why don't we try to use the item again? And we're missing the spear now. The spear got removed. We have a potion and a thumb drive. Let's try and use the spear again. I don't even have a badass spear anymore. Let's try and defend in that case. Okay, so he burninated me. I lost a little more health. I'm going to defend again. Raise my shield up. Okay, do it again. So I'm at 11.5 health. Let's use an item now. Let's use our potion. Oh, fuck, I got a name error. We have a syntax error here. We typed in something wrong. It says on line 60 in our code. It says protagonist HP equals player HP. Or here's a typo. We don't have any kind of value called player HP. It's supposed to be protagonist HP, right? We typed that in wrong. So that's at line 60. Let's go up here. Look in the bottom. It says line 62. That's a feature that's in idle, but not in Notepad. Last time we used Notepad to prove that you could use Notepad, But one feature that idle has that Notepad doesn't for programming is line numbers. So line 62, we want line 60 right here. Right? Protagonist HP equals protagonist HP plus 10. Right? Let's go back and look at our code here again. So the error it gave us was that the name player HP is not defined. We were trying to use this variable player HP that we didn't even have. There is no variable by that name in our code. I mistakenly entered in the wrong name. Let's rerun our code in that case. Right, run the module. And we're going to call them the same names as last time. Nerd raise. And should be reading. And now when he burninates me, he should have an exclamation mark at the end, right? Let's defend. There we go. See, so we actually fixed this this grammar error here by putting a punctuation at the end of that sentence. Let's defend again, lose some health here, let him burnate us a little bit. We're taking half damage here by defending. Now let's use an item, and let's use our potion. Okay, so Nerd Race chugs a delicious potion. I got my health back. Nice. 24.5. I was at 14.5. Now I'm at 24.5. He attacked me. Oh, look, I'm still defending, though. We have a bug. I took half damage right here. Right, I'll show you guys why we took half damage. Go to our code, and when I defend, let's go back to our defend command. Right here. If the player's choice is defend, we change this flag. Player is defending and becomes true. Then it says, you know, so-and-so raises their shield, prints a blank line, then the monster gets his turn. Right, so change this flag, this Boolean flag, to true. Down here in the monster's turn, when he attacks, it says, if player is defending, then do half damage. So that's true now, right? That's true, we were defending. Otherwise, if it's not true, then do full damage. Right? But the problem is that when we attack, go to the attack command, it changes this flag. Player's defending becomes false when we attack. Right? But not if we use an item. If we use an item, that flag persists. So we can actually stay defending the whole time. Instead of having it be when the player attacks, let's just have it change that flag whenever the turn starts. Right? So now we're saying here, when the player's turn begins, this flag becomes false. He's not defending anymore. And he can redefend right here if he wants to. But otherwise, he's going to be not defending. So that fixed that bug right there. What's up, Zanzi? Welcome aboard, dude. Let's just water real quick. Good evening to Average Gaming. How are you, my friend? Good evening. Thanks for the follow, Roro Smurf. That's a sick-ass handle. Roro Smurf. So today, we have looked at a few new things. Right? We actually learned about the elif statement, the elif code block. That's kind of cool. We learned about the continue statement, which will make a loop skip the rest of its code and go right back to the top. That's true of for loops and while loops. We learned about a new data type called a list, which can store a bunch of things and then iterate over them using the for loop. The for loop will iterate through a list. And we can also use lists as conditional things, like if this item's in this list, right? If spear in list. That's kind of cool. Happy to hear you're doing all right, Zanzu. Wish you were doing, like, amazing. I know you're exhausted. Probably don't even have a weekend, do you? Your weekend's probably going to be all work, knowing you. Hang in there, bud. This man's working his ass off. Our code's looking pretty noodle-ish. Right? And that's because, what's interesting about programming, guys, because I'm new to programming, I might not realize this. As we use simpler concepts, right? We're using very simple beginner concepts, right? The result is that our code, as our program gets more complex, our code gets longer and longer and longer and more complicated. Look at how long this code is now. But what's cool about programming, though, is that as our concepts become more evolved, we can actually make our code smaller and more elegant. So as a result of us sticking to the most basic of concepts, our code's getting kind of long and ugly. But why don't we start to work on changing that? We have another half hour left on the stream here before we play some Mario 64. So why don't we find a way? What's a good way to make this? I'm trying to think of a way that I can introduce a new idea to you guys and have it make this a little bit neater. Okay, well, I don't know. Actually, I do know. Why don't we define a function? Can I do this? Is this okay if I do this? Yeah, it is okay for now. We're going to make a function that will have these commands execute, essentially. Right, so let's go up here to the very top of our code. We've used functions, right? We've used this input function here. Right? It's all you do is you give the function name, you call it by using the parentheses, and you can supply arguments between them, right? Between the parentheses. In this case, the input function will take a string to prompt the user with for some input. The string function will take some piece of data and turn it into a string for our usages, right? Such as a number like the text, a number like the HP, make it into some text we can print off. We've learned about the print function, prints off some data onto the screen. We learned about the remove method of a list. Right, this list down here has a remove method. It's kind of like a function. It basically is a function, but it's attached to that list. So it actually has access to that list. It can manipulate it. It can do things to that list. Kind of cool. We're removing the spear. Right? The spear is the argument to this method, which is a function attached to this list. All right, but we can make our own functions too. That can also take their own arguments. Let's make our very first function, guys. In fact, before I even do that in this, I'm going to make a new file. Let's demonstrate the very basic of functions first. We're going to save this as, functions example. It's okay, Zanzu. You're welcome to lurk if it pleases you. If you're busy or whatever. That's true of anybody, man. You don't got to be talking in the chat the whole time. I know you guys got shit to do. We're going to make our own function, right? We're going to say here, def. That's how you define a function. It means define. Space, define new function. We're going to call this, my function. Cool, right? We're going to give it no arguments. We're going to put a colon there. It might look familiar to you guys, right? So if any line ends in a colon, starts a new code block. So we have a code block. It's indented, right? It's a new indented code block. Let's say, return hello world, right? A one-line function. Then we're going to say print my function. There you go. Let's run this code here. Run module. It prints off hello world, right? So just like an if block or a while block or an else block or an elif block or a for block or a, whatever kind of block you want, right? A block in Python is an indented line of code that may or may not run. It'll only run under a certain condition, and it always starts off with a line that ends in a colon. So when you define a function, you're making a code block, and the condition of it running is that this function be called. Right? So that's what we're doing here. 2F says, do you mind giving me the cliff notes on the elif statement? I was late to class. Certainly, dude, certainly. Let's go back down here. Sorry about the interruption, guys. Let's go review elif real quick. So we have this if and else statements, right? Like right here. Right? Well, let's just go back to we'll go back to our other one, and we'll make it real simple. Right here to our functions example, right? We'll say, if, we'll say, toAverage, is late. Right? That's going to be true. He's late. We're going to say here, if toAverage is late, then print off, you're late. And then give him a really angry face so he knows that he's being scolded. Thanks for the follow, Dobino. Kind of a cool handle. You guys all have really cool handles. Else, print off, thanks for your courtesy to average, if he's not late. All right, so we have this if-else statement, right? So if this is true, then this code block will run, right? Else, or otherwise, this code block will run. You probably already know that much, right? But elif is a way to condense, what's the word I'm looking for? Indentation, right? Indentation. So we're going to say here, toAverage is late. We're going to say, he's, let's just say here, toAverage lateness, his lateness. We're going to have that lateness be, he's 10 minutes late, right? We're going to say here, if toAverage lateness is greater than 0, we'll say it's greater than 5. More than 5 is going to say, you're late, right? If he's late by more than 5 minutes, he's super late. It's really annoying. Say otherwise, you know, he's on time. So even if he's, you know, 4 minutes late or even 5 minutes late, he's more or less on time. Let's run this code, see if it works. Right, he's late, right? He's 10 minutes late. He's actually later than 5 minutes. I'm annoyed, clearly, just like in real life. Not really. But in this example, look at how annoyed I am. Right? Very, very annoyed right there. Because he's more than 5 minutes late. Here's what we're going to say here. We're going to say, you know, else if to average lateness is greater than 0, right? We'll say print, you know, welcome aboard to average. I'm going to give him this look right here. I'm going to give him a look like this, right? Like this. No, that's not angry enough. How about we give him a look like this? There we go. That's perfect. All right. So he's a little bit late, right? But he's still, you know, we're still happy he's here. He's a little bit late. We're gonna say yeah, otherwise, he's totally on time. Right. So let's lower his lateness now from 10 down to 3. Okay. Run this code. Okay, it says welcome aboard to average, and give him a little bit of a dirty look. Right? Not a really dirty look, but a little bit of a dirty look. Because, you know, he's a little bit late. He's 3 minutes late. Let's make it 0 now. If we make it 0, then we're you know, we congratulate him, right? So thanks for your courtesy to average, right? He's on time completely. So we have a kind of like a nested if statement here, right? We're saying if he's more than 5 minutes late, then print off that he's super late, and we're angry at him, right? Otherwise, if he's, you know, if he's not more than 5, well, is he more than 0? And if so, well, then we're kind of, you know, annoyed, but it's all right. He's not more than 5 minutes late anyway. Otherwise, print off, you know, you're on time, thank you. Right? But the problem with this is that we have a lot of nesting going on here. In fact, we want to do even more. We could have this stacked like 10 times, right? Have different messages for every level of lateness. But the problem with that would be we'd be indented like way fucking over here. We'd be way over here with the indents, and it'd be kind of hard to read. Thankfully, Python supplies an elif statement, which combines else and if into one statement, so we get to indent it much less. So we can say here, instead of saying else if, and then keep on indenting forever, we can just say elif, you know, we can actually unindent this now, you know, and then we can say else at the end. So we're saying here, you know, if to average is more than 5 minutes late, print off, you're late, and really angrily. Else if, or elif, to average lateness is greater than 0, print off, welcome aboard to average, but still looking kind of a dirty look. Else, you know, if he's not late at all, then print off, thanks for your courtesy to average. Right, so basically, elif is just else and if combined into one statement to give you less indenting to do, basically, and saves you a line where you'd be typing in the other if. It's just else and if combined. So if he's more than 5 minutes late, do this. Else if he's, you know, more than 0 minutes late, then do this. Else, you know, finally, if none of those are true, then do this. That's kind of how elif works. So dark Pegasus says it's super educational stream, but it's 4:30 in the morning here. I'm going to watch it later for sure. Good night, Dark Pegasus. Thanks for following, dude. Welcome aboard, man. If you guys want to watch more educational Python content, go check out my YouTube channel at youtube.com/VencaboutArchive, or just search on there for Vencabot. You'll find me that way too. We have an entire playlist there called Intro to Python, where we have the entirety of Season 1 on there. It's Pokemon. You know, with 6 episodes. We started off as total beginners and learned how to make a Pokemon battle by episode 6. It's pretty cool. We have Season 2, which is a textual adventure. It's only halfway uploaded right now, though, sadly. I have to kind of get that out for you guys and publish them. And this is Season 3, guys. We're working on kind of like a classic JRPG, one-player kind of ordeal. Kind of like Pokemon, but not quite. We have an inventory in this one. 2 averages, gotcha. Makes sense. Looks clean. Good stuff, dude. Glad you could figure that out. I'm kind of rushing through things here a little bit. That's kind of how elif works, though. Makes it a little bit neater. Not quite as much indentation. Thank you, Chwike Lol. Chwike, maybe it's T-Wike or T-W-Ike. I think I can parse that. Welcome aboard, man. I'm David. Well, nice to meet you guys. Okay, so enough about the elif. Let's look at functions. We've used functions before, but now let's define a function. We made our own function right here. It's called myFunction. Right? It takes no arguments, and all does is return this data. And what return does is it actually gives us some data back to assign something else. Let's say, you know, let's just say my string equals my function, and then we run it, right? We can say here, print off my string. Right. Like that. Let's run this code here. It prints off hello world, right? So basically, we run my function right here. As you can see, we defined it right here, and we ran it right here. You can see because we have the parentheses at the end of it. We ran that code. And then it spits out this string, hello world, with the return statement. And that value is then saved into my string, which we can print off or do whatever. We can say, we can print off extra data. We can say, we can say, our function returned the string plus my string, right? So that'll kind of, it gives us a value back, basically. That's what return does. But we can also supply our own arguments too. We can name them right here in our function definition. We can say my function will take first number and second number. Right? It takes 2 arguments now, right? And then it returns the value of first number plus second number. We're gonna get back my number out of it. We'll call it my sum. Then we can print off, it's gonna be a number, right? Let's print off a string version then of my sum. We're gonna use the string function we know about from before to turn a value into a string temporarily, so we can print it off. Right. So let's look at our function before we even run it, right? We're defining a new function. It's called my function. We named it right here. Then we can supply some arguments to it. We're gonna call the arguments first number and second number. And then because it's a code block, it ends in a colon, of course. The next line's indented, of course. And we're returning the value of our arguments being added together. So let's try this. We're going to try this with arguments now, right? We're going to give it arguments 2 and 4. Let's see what happens here. Run it. Our function returned the sum 6. Okay, so we put in 2 and 4, we got 6. Cool. So that's pretty basic. But when you imagine how much we can do with that simple idea, it becomes incredibly powerful, right? Even if it's something this simple, the fact that we can give data to a function, and then have it spit data out that's based on the data we put in, that gives us so much power. It could drive a man insane and even give him, delusions of grandeur. Sometimes when I program, I think I should take over the world. But then I looked at my bank account and I realized that maybe I'm not all that. So we have this. We'll change the name of it. We'll change the name of this function to like number sum. Right? We can run our function number sum, and then we supplied some arguments, right? And we named these slots. We named the slots up here, right? And this first slot's first number, second slot second number, and we're using these arguments to get data back out, which we're then saving. It's return value. The return value will spit a value out of the function. We're running it here, and we're catching whatever it's spitting out with this assignment operator into this value, my sum. Then we're printing off that sum right here. Coolio. That's really all you got to know about the basics of function definition. Right? You can do anything. You can have it multiply. You can have it be 2 strings. How about we'll say like we'll make a new function called create greeting. Right? We're going to supply 1 argument. We're going to say person's name. We're going to return a value here that's going to be, hello, plus person's name, plus exclamation mark, right? We can get, we'll just go delete this line here. We're going to print off, our function returns a greeting. We're going to add in create greeting to, to average. Or we can greet Ryan in Pixel Outlaw. Right. So we're adding in whatever's returned by this function here. Let's see what happens when we run this code. Okay, so it says our function returns a greeting. Hello, Pixel Outlaw. Right? Because we right here we got a string back from this function call. Right? So we're adding the string returned by this to this string. And the string it returns is it takes the argument we supplied, person's name, and then adds hello to it. right? So we got a string back, and we can use that string, here. The return value kind of gives us this cool... So basically, when you have a return value like this, you can treat the function call as though it were data. We're adding in this function call here because the function call is returning a string, right? So we're actually adding in the result of this function call, right? This function call here returns a result right here. And this is the value we're going to be adding into this string. Let me print it off. Kind of cool. What's up, Ryan? How you doing, dude? It's that Python. Awesome. But not every function needs to return data, right? This function here returns some data, so we can use it essentially as a string, because it's returning a string, right? We can also have like a function that just does some cool shit. How about like, let's say, print off, Ryan is a young guy. Print, our company needs him. Print off, Ryan is a young god. Print, our company needs him. Print off one more time, Ryan is a young god. Print off, our company needs him, right? So we did the same thing 3 times, and each thing we did took 2 lines, right? Well, I can reduce this to taking 3 lines with a function call. All we gotta do is define a function here. We're gonna call it celebrate Ryan. It needs no arguments at all. There's no arguments here. So this one took a person's name to greet, right? And we use that argument as a part of our function. This one here doesn't take any kind of data. All it does is it prints off, Ryan is a young god. Our company needs him, right? So instead of typing it in, over 6 lines, we can just say, celebrate Ryan. Celebrate Ryan. Celebrate Ryan. Right. Let's run this code. So it printed off, that same lyric 3 times in a row. Right? So by putting all of our code into this function call, we can actually save ourselves space later in our code, right? Which is very useful for indenting. Let's say that we have some kind of noodly-ass code. Who would write noodly-ass code? I don't know. Maybe this guy? Look at how long and deeply indented this code is. It's kind of hard to read. Look at all this shit. Some of these indents go mad deep. Right? Instead of having this shit be way over here, why not make a function up here and then just call that function down here? Right? That way it doesn't be indented so deep. I'm going to demonstrate that in a second here. What's up, Matthew? Matthew Siver? I'm learning Python for ethical hacking. Ethical hacking. I'm not sure what that means, but welcome aboard, dude. Jiffy says, hey, yo, just stopping by to say hi and have a good stream. One day I'll have internet good enough for 720p 60. Jiffy, it's so weird. We actually talked about you earlier today, dude. You were a character in our game earlier. Welcome aboard, homeboy. Yeah, Jiffy, have you tried turning off... I'm going to get in the chat real quick in case Jiffy's there and can't hear me. Twitch.tv/Vencabot/chat. Blah, 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 blah. At Jiffy Beefy. Hey, Jiffy, have you tried clicking the gear icon on the Twitch player and disabling low latency? Oops, I'm sorry. I wanted to do at Jiffy. I'm sure he's still here. That makes it much easier to download, and you won't get so many stutters. I'm sure he's still around. It was a pleasure having Jiffy here anyway. A person who hacks into a computer network in order to test or evaluate its security rather than with malicious or criminal intent. Okay, well, as long as you're, underemployed from that company, then by all means. But if you're not under that company's employ, it would still be illegal, of course. Yeah, if you're trying to be a security expert, then by all means, definitely. I recommend that. Okay, so, Ryan says, I have chances every once in a while to use it at work, using it to clean up some CVS files currently. Nice. Yeah, Python is a pretty nice library for that, as I recall, right? A nice CVS library. I'm hacking myself with virtual machines, so no harm done. I gotcha. Testing your own security. Probably a pretty good habit. Okay, so let's go back to our code here. We learned about defining functions, right? Why don't we then define some functions? Let's go up here and define a function right off the bat for using a spear. Def use spear, right? And we're going to give it some data to do its job correctly. It's going to need a few things. It's going to need the monster's name. It's going to need the protagonist's name. And the protagonist... it's going to need pretty much everything from the protagonist, right? His HP and his attack power. Right. So need all that data from the protagonist. It's going to also need the monster's HP and its name. Monster name, monster HP. Yeah, that's a very long line of code, right? Very long line there. We have a lot of arguments for this function. It needs a lot of data to do its job correctly. You know what I mean? It needs a lot of data to do its job correctly. So what we can do is we can use a hanging indent in Python. Hanging indent is I put pass here. So we need to define a code block, right? The code block's data is indented 4 spaces in. This would be the code block right here. But you can have a hanging indent to make your code more readable. It's like this. I'll demonstrate that to you guys real quick. Okay, so what I did right here was I indented the data from our as our arguments list, basically, and indented 8 spaces. That way, it doesn't get confused as being part of our function, but also it doesn't break the line. I mean, the line doesn't go on forever. That's something you can do if you want to make your code a little bit neater. It's not really necessary, though. You can have the line go as long as you want, really, if you want to. I'm going to indent this shit with a hanging indent, though. What's up, Steve? He says, hey, I'm back for half a second. Just stopped by to wish you all good night and good gift. You going to bed, Steve? Have a good night, homeboy. It's pretty early for you, huh? Oh, there is, Jiffy. There is. Let me go back here. Back to my chat room. I'm not sure Jiffy can hear me because of the lag. I guarantee there is. It exists on both mobile and desktop Twitch players. I don't know exactly where to find it, though. But it'll make mobile viewing, especially, a lot easier on you. Well, that was weird. Okay, whatever. Cool beans. I try to maintain 80 characters or less, but sometimes your lines just get a bit long in the real world, yeah. I usually try to aim for, 73. But you're right, especially when you have long variable names like me. I like to have long variable names, so you know what they are. Right? You can have this be, you can call it X and Y if you wanted to. You can call this just X. Some people do, the madmen. Right? Call this Y. I think just use it the same way, X plus Y or whatever. But if you call it something that's easier to understand, it'll save you trouble in the long run. Trust me. Trust me. Okay. Okay. Cool. Protagonist name there. All right. So we're going to use a spear, right? Let's go down here and copy paste our code for using the spear. Let's go down here. Where's the spear at? Right here. Copy it. And paste it. Cool. It's really deeply indented though, right? It's unindented now. Like that. Okay. Coolio. Let's actually get rid of that line. Alright, so now all this code for using the spear is down here. So we're going to say here, use the monster's HP, right? Adjust the monster's HP. We actually have that as a argument now. So we know what his health is. That's cool. And we have the protagonist attack power, right? We actually got that as an argument. Cool. And then we have his HP as text, right, as of right here. We have the protagonist's name. We got that as an argument. Okay. We have the monster's name. It's right there. Okay, cool. Gotcha. Then we're going to actually return the monster's new health. Right. Here you go. Cool. So let's go down here to our spear code. Right? Down here in the spear code. Right here. So here's where we're using our spear. instead of doing it with all these lines of code, let's just say use spear and give it the arguments it needs. Protagonist name, protagonist HP, monster. Protagonist needs the attack power, right? Protagonist attack. Then it needs the monster's name and the monster's HP, right? That's all it needs. If I'm not mistaken. Let's go double check. Name, HP, attack, name, HP. Okay, okay. Now we can do another hanging indent here, right? Let's go back over here. Okay. We can remove the spear. Okay, cool beans. We have an ILE RPG programs at work, and var names are limited to 7 or so characters. Oh my god, that sucks. It's good RPG and COBOL langs died. They blow. Limited variable names, that really does suck. Alright, so we have this cool function now, and it returns a new value for the monster's health. We're going to say here, monster HP equals the result of use spear. Right? So we're going to call this use spear function with all this data in it. Right? So we're going to give it all these arguments, going to run this function up here, and return the monster's new health. Okay, cool. But we have a problem. And we have, what, about a little bit less than 20 minutes on stream still? Let's solve this problem. The problem we have is that... I don't know, do I want to address this right now? And let's not. We'll save it for next time, guys. But we're going to actually make this a lot cleaner. Our problem here is that we have too many arguments. Look at all these arguments right here. And it's quite a nice little stack of them that we need to use. So it kind of makes our code still kind of ugly. In fact, this code is kind of complex, because it still asks if they have the spear outside of the function. If they have the spear, then run the function, and then remove the spear. Otherwise, print off this data. Wouldn't it be nice if all this code was inside that function? But the only problem with that is that they would need to also supply the inventory to this list of arguments. And we already have 1, 2, 3, 4, 5 arguments. That's kind of a pain in the ass, right? I don't want to add a 6th one. But next time, guys, we're actually going to make this code a little bit neater by condensing our game state, that is to say all the stats we need, into objects. So we've been using mostly what's called functional programming today, guys, in the last couple streams, which means that we've been saving our data as variables right here, like, the name and the HP, and the HP is text, and the attack power, and whatever, this flag here, if they're defending or not. We've been saving them as variables, and then using those variables down here as arguments for functions in some cases, such as in our new use spear function. And that's pretty much how our code's been running. Very, very straightforward. Just a bunch of floating variables, right? Even though we have this protagonist who has all these attributes, he has a name, he has HP, he has attack power, and he has a flag he's defending, he has an inventory. But although he has all these things about him, he is not, within Python, a single thing, right? In our mind, he's a single thing, but in the program, he's just a bunch of loose variables. He's just all these random numbers. You know what I mean? These are not attached to each other. They're just individual numbers. But what's cool about object-oriented programming, such as in Python or Java or C++, most modern languages, is that you can actually attach all of these values to a single thing. We can actually make a player and give him all these attributes and that sort of thing. And it makes our code a lot easier to read and a lot easier to write. Like I mentioned earlier, guys, as we use simpler programming ideas, it's easy to understand at a base level. We know what a number is, right? We know what a string is. It's a bunch of text. We know what a Boolean is. It's true or false. But if we don't evolve our understanding of Python conceptually, our code is going to get longer and longer and uglier and uglier. Look at all this code we have today. It's pretty cool code. It does a pretty cool job. We have a pretty cool working game now. That's sick. But what's really nice about Python is that it's a very beautiful language. And as we understand more of its syntax, more of its tools we have access to, we can make our code look a lot prettier. This code right now, let's go check it on the very bottom, right? The code is 109 lines right now. 109 lines of code. And in the near future, we can actually shorten that dramatically. We can shorten this code dramatically, make it much easier to read, much easier to scroll through, easier to see what's going on. If I scroll past this really fast, right, you can't tell what the fuck's going on. Right? There's a whole bunch of indented lines, and it's kind of hard to see what's actually happening here. But next time, guys, we're going to be using some objects, some dictionaries, some methods. We're going to be actually having things that work a lot nicer and are much easier to read and understand. But I mean, for today, for a couple streams, we've learned a lot, right? In fact, let's go update our notes over here. Let's go back to our notes and update this. Right. So we have these lists, right? So lists by using the in comparison operator, we can get Boolean true or false values based on whether or not some piece of data is in a given list. Let's go look at how we utilize that today as our end of the stream review here. So we go down here to our item usages, right? We're saying here, if they want to use a spear, for instance, right? If they want to use a spear, let's say if they want to use a potion, right? We're saying, hey, only run this code, the potion code, if potion is in the player inventory, right? So we used our very first list today. This player inventory is a list. It starts off with a square bracket, and it ends in a square bracket. That's how you know it's a list. And it contains a comma-separated list of data. In this case, they're all strings. Right? We have a string called spear, a string that's a roll of toilet paper, a string that's a potion, etc. And we can actually, aside from saying, if this number is bigger than this number, or if this string equals this string, we can also say if this string or this data type is in this list. That's a pretty powerful tool. So only run this code if this list contains this data. Right. Also, we can run a loop over every item in the list. It's called a for loop. And it allows you to go through each item in the list and give it a certain variable name. Then you can do whatever you want to that variable, right? We use that in one spot to start with. I'll show you guys that real quick. When we show the player what they're carrying, right here. So when they choose to use an item, right? If the player's choice is to use an item, we're going to print off you have, and then for our item in player inventory, print 4 blank spaces followed by our item, right? So it's saying for every item in this list, give it this name, our item, and then do this thing to it. And this is going to happen for every item in that list. Right, let's go look at how that actually works in our code. Let me actually get rid of this. I don't need this example anymore. Run our module. Okay, so what's your name, son? I'm going to be David. And the monster is going to be John. I want to use an item, right? It says here, you have spear, a roll of TP, potion, and thumb drive. So we have this list that we start off with, right? It has a spear and TP and potion and thumb drive. And then we're saying here, when I try to use item, it says you have, and then for every item in our list, we print 4 blank spaces and then that item. Right? So here's the name of it. We can change the name if we want to. We can change this to, inventory item. Right? For inventory item in the player inventory, print off 4 blank spaces and then print off, the inventory item. We can name it whatever the hell we want, as long as we stay consistent. Right? If you look at our code, what's happening is that very thing. It's looping over that list. And for every item in that list, it's putting 4 blank spaces and then the item. Then does it again. 4 blank spaces, and then the next item. And the same thing. 4 blank spaces, and the next item, right? It's kind of cool. So we have 2 kinds of loops now. We have a while loop, which will run as long as its condition is true. This while loop will run as long as this is true. And we have a for loop, which will run for every item inside of a list. That's kind of cool. So lists are a really cool feature type we learned about today. A really cool data type, I mean. Cool. Sweet. We learned about elif. We learned about that right up here. We learned about function definitions, right? Today we learned about function definitions. So in the past, we've been using Python's built-in functions. A function is used by giving its name followed by parentheses. That's how you call it. Right? You can supply arguments to a function to help it do its job by putting data between those parentheses. Right. When you define your own function, you do it using the DEF statement. DEF is followed by a space, and then the function name, or let's say the name you want, right? The name that you want to call the function by. The name is followed by parentheses, and within those parentheses, I want to use ES for parentheses. You can supply a comma-separated list of names that you want to use for arguments that are supplied to that function, which it can then make use of. Let's go look at our function we defined. So up here we defined a function, right? We called it useSpear, right? So define DEF, calling it useSpear, followed by a parenthesis, and then we're going to supply our arguments we need, and we're naming them, right? So here's all of our arguments we want to have, right? Once we've named them all up here, we can use them down here. So when the user when the programmer calls this function, they have to supply all this data. When we supply it, we can use it by name, right? And here's the names we're using up here. We'll go more in depth about this next time, guys. Next Friday, we'll go more in depth about functions and arguments and that kind of thing. But basically, we got these data types, got this data from the arguments, and we're using it inside of our function here to do some kind of work. Right? Here's the work we're doing. We print off some data, we do some calculations of the monster's health, then we return the monster's health, right? Which we can use to then save that outside of our function. Down here in useSpear, you can see that we've actually saved the monster's health from this function. Let's go take that little note here. I know it's a little bit complicated, guys. I'll make it more clear next time, I promise. We're kind of in a hurry here. You know, like any code block in Python, the function definition line ends with, you know, a colon. And the meat of the function is indented. That's true of any code block in Python, right? We talked before about how code blocks in Python are pieces of code that only run under certain circumstances, such as a while loop will only run if its condition is true. Same with if. Same with for. You know, for will only run if that list has things in it. Else will only run if the previous if did not run. And finally, function calls are a block that only run when that function is called later in your code. Okay. Yeah. Once a function has used its arguments, I think for the follow, Digifus, it's kind of a cool name, Digifus. I'm David. We're ending our stream here, dude. We're going to be coming back on Friday, though, with more Intro to Python. And next week, guys, on Monday, Wednesday, and Thursday, around the same time slot, we're going to be doing some game development. It's not going to be like a tutorial like this one is. It's going to be more like me and my friends talking about game dev, starting to work on a new game. If you guys want to join us, by all means, it's totally beginner-friendly. We can help you learn Python, help you learn whatever you want to learn. We're going to be doing some graphic design as well, probably, some music at some point. But I think on Monday, it's going to be mostly game design discussion, like what makes a good game. We're going to be doing that next week for our programming streams. But on Friday, it's going to be always Intro to Python. It's going to be total beginner stuff. We're going to be picking up where we left off here on Friday, next week. So what the function has used as arguments to do some calculations. It can return data back to the outside world with the return statement. A function that has a return statement can essentially be treated like the data it's returning. Right, let me go demonstrate that real quick. So we look at our function here, useSpear. Use spear returns an integer, returns a number, right? The monster's health, whatever it may be. So here we're taking all these stats, all these things we need to run the program, run the function, all these arguments, and we're doing some calculations here on the monster's health. We're reducing the monster's health from the spear damage and printing off some stuff that might involve somebody's name, right? So we need these names to run our code. We have to have their name for these little print statements here. Then we're going to return the monster's new health. So the monster's health has changed inside here, right? In order to use that change outside of our function, we have to return it out, because once a function ends, all the data inside of it goes away. It goes bye-bye. Right? This function is like its own little universe, basically. It's its own little encapsulated, nice, neat, tidy bit of code that once it runs, things that happen inside of it are done for. It's kind of like what stays in Vegas happens in Vegas. What happens in Vegas stays in Vegas, right? What happens inside a function stays in that function until you return it out. So we're returning out the monster's new health. And because we're doing that now, this function call can be treated like a number. Let me just go show you how that works. So down here, we are saving the monster's health as the result of this function. So this function here, we're calling it, right, with all these arguments. It's giving us back a number, and we're saving that number as the monster's health, right? And because we're saving it out here, this is permanent now. Right? But if it happened inside here, it wouldn't be permanent, because things that happen in the function just die in there. Right, so we're kind of like taking in some data, then we're selectively choosing what data gets out of it. And that's very important for making your code tidy and keeping it bug-free. You don't want to be returning all kinds of data out of there. You want to return just what you need, and only give it just what you need in terms of arguments. We're going to talk more about that next Friday, I promise. I know it's a little bit much, guys, a little bit much, but we got a lot accomplished today, I feel like. Our code is pretty cool right now. So let's go look at our notes again. Okay, so these function definitions, we're going to talk about that more next week, right? These functions. So what else do we have here? We got lists, we got for loops, we got function calls. I think it's really what we covered today, right? Not too shabby. So now our code, for being our second day programming ever as beginners, is pretty fucking ritzy, I think. We have this cool battle going on where we can name our characters, we can name our hero and our monster. They have their own attributes, their own attack power, their own HP. The player has an inventory he can utilize. And when the player attacks, he uses his sword. When he defends, he reduces damage on his next turn. He can raise his shield up and take half damage from the monster on his next turn. He has these items that are consumable, right? When he uses them, they have an effect. But after that, they get removed from his inventory. And in our next stream, we're going to be buying stuff. Let's use a spear, Zanzu. Use spear self. No, Zanzu. No. We don't advocate self-harm here. But yeah, so we can use these items like the spear, right? So we hurl the badass spear. Now if I try to use an item again, I don't have that spear anymore. If I try and use it, it tells me I don't got the spear anymore, right? So we have an inventory now that can be updated in our program. We can use things and remove things and add things in the future. In fact, I think next time, guys, I want to add a shop to our program. We're going to actually have money our player can have. Might even be able to get money from killing this monster. And then use that money to buy potions and spears and that kind of thing. Buy some TP, you might need it. You never know. Always gotta make sure you have that. But until then, guys, I'm going to be ending this stream and coming back on Monday, Wednesday, and Thursday with some game development. It's going to be not quite as much of a tutorial. And then on Friday, of course, we're going to return to this game, Intro to Python, on Fridays here from 6 to 9 p.m. Eastern. We're going to be talking about total beginner stuff, and picking up where we left off with function definitions, dictionaries, and objects. It can be like classes and that kind of thing. It's going to be pretty cool, I think. Our program's going to get a lot neater and a lot more powerful and interesting. If you enjoy the channel and want to help out, check out Patreon, patreon.com/Vencabot. I stream for 40 hours a week, every week. It's a lot of work. I usually do mostly gameplay, like a Street Fighter 3 Third Strike, a Smash Brothers. We're going to be playing, in a few minutes here, we're going to be playing Super Mario 64 speedrun. But usually in this time slot, in the start of our stream, we do like creative stuff, whether it be music or programming, that kind of stuff. And on Fridays is Intro to Python all the time. Even $1 is a huge help. $1 helps me buy gas and groceries and that kind of thing. If you're like me, you're totally broke, right? You enjoy the channel a lot, you want to help out, but you're not exactly rolling in dough. Maybe you're a student or you're working part-time. You can get in the chat, come say hi for free, like Zanzu. They stream a lot more fun and interesting for me here as a host. Also, you can follow on Twitch, tell your friends we're here, save clips if you're watching gameplay especially. Check out YouTube. Go ahead and search on there for Vencabot. You'll find me there on YouTube. It's a lot of videos, more than 1,000 videos, many of which are Intro to Python. Go watch me make Pokemon from scratch. Over 6 episodes, the Pokemon battle. You can make your own Pokemon, make your own moves. By the end, it's kind of cool, and things of that nature. I'm gonna go very short break, guys. Come right back after I've eaten some food and got the stream set up for N64. I will see you guys very shortly with some Super Mario. Zon says I want to be able to split the spear in two, so I get two halves to throw. You have only one side will have the pokey bit, Zanzu. Precious food, dude. In my case, food just means slim fast. But you can still throw the other end. Okay, okay. You could also use it to please a woman. Nice fucking Courtney Miller combos, Kenny! I'm thinking wrong, Holy shit. Good stuff, Nia. I'm not gonna make it to Makai. I dropped out of Makai to go to Texas Showdown, I'm afraid. I would love to meet you there. My plan was to go to Makai originally. But I can't afford to go there and also Texas Showdown. I really can't afford to go to Okay, Zanzu, I got it. Okay, that's pretty smart, Zanzu. That's pretty smart. You're thinking outside the box. Zanzu's thinking outside the box. I got you. We'll do that next time, Zanzu. We'll let the player split the spear in half. You hungry too, Zanzu? Are you still at work? You can't eat? The Superman dive is a really shitty move. It's really great in the air. If it's air to air, it's just really great. But if they're on the ground, it's you wish you hadn't hit it. Oh, right. He didn't work it. Herb Durkin, disgusting. Yo, ban yourself, bro. I had to clean and scrub for 3. So still was a 7-hour day. That sounds terrible. Oh, no. Faust. At least you're home now, right? Don't learn from Herb Durkin, dude. Don't learn anything from this guy. Don't play Makoto like this. Play with honor. Yo, if he gets that. Oh, man. If he got that, would have been... What'd you eat, man? Well, pancakes are fucking delicious, though. Who cares if it's balanced?